So I had a couple more examples I wanted to do and then really just open it up for questions. Since y'all do have homework due tonight with a quiz tomorrow. I don't know if it was a typo when they made the schedule for this course, but I double checked on the schedule and it said tomorrow's quiz was over 4-1 and 4-2 only. Oh yeah, we have a quiz tomorrow. You always tell quiz days, people show up. So tomorrow's quiz is technically only over 4-1 and 4-2, but I picked a problem for 4-1 that overlaps with 4-3. There's a hint. Or the skill you use shows up in two places. I don't know why the homework's due if it's not on the quiz. Yes?
Could we do number 49?
Possibly. Number 40?
49.
49? That's in that last block. Those can't be fun. Yeah, we'll look at that in a little bit. Alright, so I want to do two more examples and we can do number 49. Good, now I have a lesson plan. Before I was kind of lacking. Alright, so I don't know, there's three types of problems in 4-3 for the most part. The whole idea is the definite integral defines this net sign area. So it's a new type of notation. But then, because we know it represents, kind of like before, if you knew it was slope, you could look at the graph and kind of ballpark what the slope is. Now the idea is we can draw this region, we know it represents the net sign area. So you can, in that sense, have some equation about it. For a nice function, you might be able to find it explicitly because we know enough geometry. So if you get like triangles or circles, we already kind of know the answer. And then there were two cases where we don't. And some of that you can use properties that we talked about and some of the formulas we give. Or you could use the definition. Basically do a Riemann sum like at 4-2, but take a limit to use infinite rectangles. So 4-3 is kind of a catch-all for everything in 4-1 and 4-2 getting combined. All right. So I want to do two more examples real quick. First one is find the definite integral from -2 to 3 of the function f of x, where f of x is equal to x or x plus 3. So we have a piecewise function where it changes at x equals 2. Right. So, how should we start this problem? Two integrals, so something changes at 2, right? So like I couldn't write what f of x was here because when you go from -2 to 3, it's piecewise, you can't just like insert that into here. So the nice thing about integrals, you can say this is equal to the integral from -2 to 2 of what?
The first of x?
If x is less than or equal to 2, so this says all my x values are between -2 and 2. I only need to look at this piece. So of x dx plus the integral from 2 to 3. Now I would have x plus 3. Yes?
But 2 is not included in the second part of the thing.
It actually doesn't matter.
Okay, I wasn't sure.
And there's a technical way to do this. We're going to do this by picture. If you want to do it, we don't actually care to include the endpoints because it doesn't change the area. The correct way to do it, if you want to be more precise, would be the limit as t goes to 2 from the right of the integral from t to 3. X plus 3. Because that would ensure you're hitting the correct piece, right? So you could do it that way. But then this value and this value will end up being the same thing because this already gives you the limit value. So like I could write f of x here And now that adjusts and says, pick the correct value here. This was kind of in the notes, or not the notes. It's in the homework, a little bit of think about it. We didn't actually solve the problem. We mentioned it last week. What if you had like a vertical discontinuity? You actually do the same trick, take a limit. So we know the limit might be infinity, but by the time you integrate, you might get something else. So these are called improper integrals. Anytime you have something strange happening, you can always do this trick where you can't plug in the bound correctly, take a limit as you approach that bound. So limits solve lots of problems. Unfortunately, we don't like limits. Other than that, they fix lots of things. Alright, so we could solve it this way. And we actually have a formula for this. What would this be? This isn't the way I was going to do this, but it also shows up in this section. What's the integral of x? I should say what's the integral of x. We had a formula for the definite integral of x dx. What was it?
1/2 times b squared minus x.
Yes. 1/2 times would be 2 squared minus -2 squared. So b squared minus a squared. So that was technically a formula in this section. You don't need this one because in 2 sections we come up with this formula anyway. So you don't have to memorize it. Like we'll have a way to just derive it. Yes.
Where did the half go?
What happened?
The half on the outside of the parentheses.
What happened?
Yeah.
Oh, I was saying what's in the parentheses.
Oh.
Where did those numbers come from? It's b squared minus x squared. And then what about this one? It would be the integral from 2 to 3 x dx plus the integral of from 2 to 3 of 3 dx. What were the formulas for these? This is the same thing, right? So 1/2 3 squared minus 2 squared. What about this one?
3 times.
3 minus 2, b minus a.
Yeah.
So we actually have a formula already. What would this equal? So that's 4 minus 4. This one is what? 1/2 times 9 minus 4. And this one is 3 times 1.
Mm-hmm.
So what do I get? 5 halves plus 3. So 11 halves. Alright, so we could do this with formulas that we could, in theory, memorize. We don't. On the test, you won't have to have these memorized. On the quiz, you don't have to have these memorized. But they were technically in that section, so we could do it that way. The other way I had in mind was, what could we do if we really wanted to understand this problem? How do you tackle definite integrals if you look at it and you don't quite know what to do?
Graph it.
Graph it. See what it looks like. We know it's the area of a region, right? Let's see what that region is. So if I graph f of x, it's the function x until I get to 2. And then what is it? X plus 3?
Mm-hmm.
So x plus 3 looks like this. Same thing. So f of x looks like this. And then we said we want to go from -2 to 3.
Mm-hmm.
So we want to know from this region to here. Right? Now what happens? I want to find this area this area, these are positive. And then I also have this area. Which is negative. So I want to find the net signed area for this function from -2 to 3. But what happens?
So you have to add the blue section and subtract the red section?
Add the blue, subtract the red. Could do this as 3 pieces. What else do you notice?
You can just ignore the part between -2 and 2 because it cancels itself out.
Yeah, these cancel because they're the same. Whenever I subtract here, I add here, my symmetry. So really my integral from -2 to 3 is going to end up being the same as the integral from 2 to 3. Is that correct? Now, in general, you can't just do that. Why can I do that here?
Symmetrical?
Yeah, this says the integral from -2 to 2 is equal to 0 by looking at the picture. Is that consistent with what we had here?
Yeah.
Yeah. So the formula told us the same thing? All these have to be consistent with each other. So then how do I get this area? So this is the area of this piece, which is a trapezoid. How do you get the area?
You can add the rectangle and the triangle together.
Okay, you want to do the area of the rectangle and the triangle? What's the area of the rectangle?
1 times the height, so that's 5. So it's 5.
This is height 5 to here. And then what's this height? 1?
Yeah. And then
So it's going to be 5 times 1 plus 1/2 of 1 times 1. So 5 plus 1/2. So 11/2. Looks a little bit different. Gave us the same answer. Which is good. Has to give us the same answer, right? Solving the same problem. There are multiple ways to do some of these. And it has to do with, do I just want to use formulas or do I want to draw a picture and use geometry? You can set it up multiple ways. I could have also add this area, subtract this area instead of just making this claim. Like you could always show more work there also. We'd already seen that play out, so I just wanted to leave it. Any questions on that example? Always use the picture to help out, especially when you have like a piecewise function. When it's piecewise, you can't really see what's happening, but then when you draw this picture, suddenly you can see what the areas would be in some sense. Or it would make sense to go from that picture to this setup, where you look at it as 2 different problems. Alright, so I want to do one more example. So this one is to really use just properties. Suppose the integral from -2 to 3 of some function is equal to 4. The integral from -2 to 6 is equal to 9. The integral from -2 to 3 of another function is equal to 2. And the integral from 3 to 6 of a function g is equal to 3. I want to find the integral from -2 to 6 of 2 times f of x plus 7 times g of x plus 1. Yeah.
Isn't this basically from number 29 and number 31, except we're just doing a different thing?
Yes.
Because I was thinking, wait a second, where did I hear those numbers?
Yeah, if you've done the homework, it's definitely easier. It's like I teach towards the homework sometimes. I always try to pick examples that are at least similar to something in the homework. Sometimes I'm more successful. Alright, so how do I set this up? What do I really need to know? So what is this going to be? This is going to be 2 times the integral of f of x plus 7 times the integral of g of x plus the integral of 1. Right? Are we allowed to break it up that way? You can always move a constant outside, and instead of adding these 3 things inside, I can add all 3 on the outside. So instead of thinking it as one big definite integral, I can make it 3 smaller definite integrals. So some of this is just used to the notation. Notation looks weird here. Takes a little while to get used to. But basically it's saying instead of solving one big problem, write these 3 smaller problems. So then what are my unknowns?
The second term, -6 of g of x, we need to get that by subtracting or adding those together.
Yeah, so let's look at this one. What is the integral from -2 to 6 of f of x? We were given that, right? That one is equal to 9. So I get 2 times 9 plus 7 times, was I given the integral of g of x from -2 to 6?
It's just 2 plus 3 because you have the other 2 integrals. It goes from -2 to 6. You just, but you have it separated into -2 to 3 and then 3 to 6. But it's 2 plus 3, so you can just kind of see that right off the bat.
Yes. Well, hopefully. That's what we're working towards. Seeing this right off the bat, oh, I just broke up the integral. These are weird sometimes. Right, so that's 7 times, I don't have a formula for this yet. So I'm just going to leave it. What's this last one?
1?
1 times 6 minus -2.
Oh, wait.
Right? Why is that? On graph 1, it just looks like this, right? And then I want to go from -2 to 6. So I want to find a rectangle of my height is 1, my width is 6 minus -2. So I think that looks less mysterious if you just draw the rectangle. Again, you can always graph these and think about intuition on some of these. Right? We're really trying to link the intuition to just the formulas. So it's 18 plus 7 times this, plus 6 minus -2 is what?
8.
But then this is the one we don't quite have yet. So, like you mentioned, I don't have the integral from -2 to 6, but what do I have? I have the integral from -2 to 3 and the integral from 3 to 6. When you look at this, you just think, hey, these 2 go away. I end up at -2 to 6 when I add these. So I can always break this up, pick a point between -2 and 6. We'll pick x equals 3. And then go from 3 to 6 for the next piece. right? I want to find the area from here to here. Instead, what do? Find the area from here to some midpoint or some place in between, and then find the rest of the area. Right? Instead of going from -2 to 6, that's the same as saying -2 to 3 and then 3 to 6. It's breaking this area problem into two smaller area problems. One on the left, one on the right. Okay. End up with 18 plus 7 times, I had both of these, so I add them together, 2 plus 3, plus 8. So 18 plus 35 plus 8, what is that?
Yeah, 51.
Okay, 51. Y'all put
61.
61. I don't get scientific calculators now. You do a bunch of work and you realize I don't know how to add. Really, it's more I don't want to add. But then we don't know how to. Alright, any questions on that one? Bonus part to this one. How could we find the integral from 3 to 6 of f of x dx?
Subtract the first one and the second one.
Yeah. Start with the big one. So, what do I know? I know the integral from -2 to 6 of f of x dx is the integral from -2 to 3 plus the integral from 3 to 6. Right? And then how does that help? Here I know the integral from -2 to 3 and -2 to 6, which leaves just the thing I need. So that would say 9 is equal to 4 plus what I need. So this integral is 9 minus 4, so 5. I mean, a lot of this is getting to this notation and how to kind of use these properties. But it's one where you can't draw the graph. Up here we could draw the graph and kind of figure out the rate of slope. Here you have to use the formula. Any other quick questions, anything? I'll probably do your worst problem in the morning. I tell you all to look at it and try to work on the all the work beforehand, but then that just means I have to do the work wrong. Alright, so you'd asked about number 51?
No, 49.
49. I want to find the definite integral from the number 5 to the number 2 of 9 plus 10x minus x squared dx. So the direction said by definition, right? Or is it by formula?
It didn't say by definition, I don't think.
Ooh, awesome. This is not the worst problem ever. 41 through 46 are the worst problem ever. Yeah. I mean, they're all good for you. That's fun. Yeah, 41 and 45 are the ones we have to do a lot of work. Alright, this one's even better. So yeah, some of the properties. Do we ever like to start at the bigger value? We always want to work left or right when doing area, right? So this is the same as negative integral from 2 to 5. Of the same thing.
Change much though, does it? You just switch the order and then you get.
Yeah. Well, you get negative sign.
Yeah, but it gets gross.
So why would you get negative sign anyway? What's happening? Really, when you think delta x is how far you move to the right each time. What would happen here? I start at 5 and move to the left. So delta x has to be negative. It's always helpful in these formulas if you think about why that makes sense. Usually we start here and move to the right as we add dx. Now we're starting here and moving to the left. That's the opposite direction, we get a negative sign. So what are those formulas? So one thing we want to do is break this apart into 3 different problems. Make sure you use brackets correctly. This negative sign is for all 3 of these.
That's why I wouldn't have switched them around.
Yeah.
So you wouldn't have to worry about that.
Yeah, it would work out anyway, because b minus a still get the same formula.
But I know I messed up.
Yeah. You can always move a number outside your integral sign, but you can't move an x. And what tells you that is the dx. dx says any x's must stay inside. You do have to put the dx on the right every time. It's supposed to look like a sum. Remember, that's where this notation came from. It's like the sum of a function, delta x. So the summation becomes its integral sign. All right, what do I get? What's the integral of 9? I should say integral. What's the definite integral here?
Constant of b minus
9 times b minus x. So 5 minus 2. So that's the first formula. What were the formulas? I was trying to remember here. Integral from a to b of c dx is c times b minus x. Integral from a to b of x dx is 1/2 b squared minus a squared. If I hadn't, what would happen if I didn't switch my balance? What he mentioned. If this was the other number, so if I did 5 to 2 here, this would be 2 minus 5. By switching them, it becomes 5 minus 2. I'm off by a negative sign. So, because the formulas work for any numbers a and b, technically I don't need to switch the order with a negative sign before I use this formula. And it's because this is a difference here, it's going to work out. What was the other one? Integral from a to b, x squared dx is equal to what?
1/3 times b
Yeah.
minus.
So the directions say look back at these formulas. These are the 3 formulas. Those are a lot easier to memorize after you take section 4 or 5. You get these for free. Alright, so this becomes what? 10 times 1/2 of 5 squared minus 2 squared. Integral of x, or the definite integral of x from 2 to 5 is 1/2 times the upper bound squared minus the lower bound squared. And then what about the last one? Minus 1/3 times 5 cubed minus 2 cubed. So I end up with negative 9 times 3 plus 5 times 25 minus 4 minus 1/3 times, what's that? 125 minus 8. it's 27 plus 5 times 21 minus 1/3 times, is that 117? You know what a degree of math doesn't mean? You can do arithmetic off the top of your head really well.
Negative 39.
Negative 39? Awesome. Yeah, I just came up with that.
Oh, no, that's the 117 divided by 3.
This is where y'all get to participate in class. And apparently I listen.
Oh, the actual answer is negative 93.
Negative 93?
Yeah. Go for it.
There you go. Class is a lot easier with a calculator. Or, if y'all have calculators and I just let you tell me answers. Does that one make sense? Any questions on that one? Those are useful formulas. Better than drawing a picture and figuring out, which wouldn't help at all for this one. Like this piece and this piece you can do by picture, right? This is essentially a triangle. This is a rectangle. This one with a parabola, that one's hard to know. Yes?
When you say we can do it with a picture, do we actually have to solve with a picture?
No. You always, the directions will either specify, in which case, yes, you have to draw a picture, or use a formula, depends on what the directions say. Or if they're vague, you just say solve the problem, use a method and solve the problem. And like, what are the options? You do it by picture, if you can get it from a picture. This piece, you're not going to be able to draw a picture good enough for that. Because how do you find the area under a parabola? Well, that's not a geometry formula. The other one is by formula, so if it's only terms like this, you can do formulas. Or you can do it by definition. And there will be one that says, it won't be on the quiz tomorrow, but on the test, there will be one that says use the definition, use the limit of Riemann sums to find the area. But that's not our go-to for every problem. That's our last resort. And 4 or 5, we come up with ways to solve this for lots of problems. And basically, we come up with formulas like this for things like sine of x dx, or more interesting functions. Any other questions?
Who wants to go over?
Sure. Oh, so what should you know for the quiz? Why not? Know what you're on. There will be one where you want to do it by a picture where it's like a Riemann sum. So 4-2 is only Riemann sums, right? Left endpoint method, right endpoint method, midpoint method, upper lower sums. There will be one where I actually give you the graph, so you can draw on the graph, where it says find the area. Right? And you have to use one of the methods. So that'll be like one of those homework problems where it was used 3, 4, 6 rectangles, trapezoids, something to find the area. We'll have one like that. And then there's another one where you probably have to use those definitions of like what's the sum of k squared, things like that. And I will give you those formulas. So I can make that more clear. I will show you part of your exam or quiz in a minute. This is all exciting for you to see part of the quiz, because I got here early and wrote a quiz today. You're going to be disappointed when you see it. This is the bottom of your quiz. Anywhere it might be relevant, we give you these formulas. Do not memorize these. Actually, you probably memorize them if you do enough of the homework. But anytime for the quiz or for the test where you might need these formulas, we will provide them. Okay? Well, you can see the file previews on the left. That's not useful. I should close this. Alright, so you get the formulas on the bottom of the page. Don't memorize those. Alright, and it's only 2 questions. Alright, so that's for the quiz tomorrow. Any other questions? Can be over anything. Oh, and I think most of y'all saw this, but if you go to learning materials, I added 2 more files to several of these where I actually posted the examples I plan to do plus the solutions. Which the solutions may not look anything like what I write on the board. It's like these are the 2 we did today. So I have those posted plus the solution file where I actually solved them to make sure they're doable. Hey, we got 11 number 2. Good. Alright, so these are also posted. And they will be there when you study for quizzes and exams. That also doesn't mean like don't come to class. I do other things sometimes. Probably not. Yes?
I just noticed that the clock is off.
Alright, y'all have 9 more minutes. Oh, they didn't reset for an hour?
Yeah.
Yeah, they may not. They'll be right in several months.
So basically, once we're out of this class.
Oh yeah. Our car is always off by 7 minutes, no matter how many times you reset the clock. Within a month, it is 7 minutes off, but it never gets more than 7 minutes off. And I don't understand how in the world that is possible. You would think it would slowly get worse and worse. Instead, it gets to 7 minutes off and decides, hey, this sounds good. Because then you always think you're late and then you realize it's faster. Oh, well, as far as car bombs go, that's the best to have. Alright, any other questions on the homework, anything? Remember that's due tonight? Yeah.
Well, hey, it's better to have it fast than slow, because then you think you have plenty of time, and then you end up being
Hey, it's
late.
great because we can tell the kids we're late and they look at the clock and leave us. Alright, any other questions on homework, anything? Chapter 4, any better now? I mean, chapter 3 set low expectations for chapter 4, I guess. Okay, we're gonna make it. You have like 2 more weeks. You just have to learn a lot about area. Actually, most of the area stuff we just did. And then the rest of it's coming up with shortcut rules, which are going to be very much based on derivative rules. So hopefully you're really good at taking derivatives of x plus 1 squared dx. There are a lot of ways to do this that would make it less effort. I don't know if it's going to do this. Alright, and this one's by definition. So what does it mean by definition? No. So we want to find the definite integral from 2 to 3. So we want to find the area of this region. And definition says this should be the limit as n goes to infinity of the sum k equal 1 to n of f of x k star delta x. So what is delta x?
3 minus 2 divided by n.
We always use the formula b minus a over n, so 1 over n. And then xk is always a plus delta x times k. where you do k equals 0 to n. If you ever forget this, what should happen? If I plug in 0, I should get A. If I plug in n, I need to be at the point B. And you can always check to make sure that's right. So this is going to be, what, 2 plus k times 1 over n. So 2 plus k over n. And then what is xk star? Yeah, now I can make a decision, right? If I use the left endpoint method, it gives me, it tells me how to choose xk star. If I use the right endpoint method, it tells me how to choose xk star. If I use midpoint method, I choose it differently. For every one of those methods, we had a different choice where they were just barely different, right?
So the question says use right sum.
It says use the right sum. Alright, if I do right sums, then xk star is equal to xk. It's the right side of the n. So that would be 2 plus k over n. So I want to find the limit as n goes to infinity of the sum k equal 1 to n of what? Xk plus 1 squared delta x. Take my x value, plug it into the function. Alright, so xk was 2 plus k over n. And delta x was 1 over n. So I need to figure out what is this sum, and then take the limit when it goes to infinity. All right. So what do you probably do with the inside? I don't have a formula for that, do I? What do I have formulas for? I know the formula k equal 1 to n of 1. I know a formula for k equal 1 to n of k. I know one for k squared. I technically know one for k cubed. So I want to use these formulas. Why do I want to use these formulas? These do things like this is this. So what happens there? It no longer depends on k. I can get rid of all the k's. If I get rid of all k's, then I can maybe take the limit as n goes to infinity. So if I multiply this out, what do I get? 9 plus 6k over n plus k squared over n squared times 1 over n. So if I write this out as several pieces, what do I get? 9 over n times the sum k equal 1 to n of 1. So treat this as just 1 here, 9 times 1 over n. What about this one? Plus, leave the k on the inside. So 6 over n squared times the sum k equal 1 to n of k. So I took off the coefficient, just to make it look more like a formula. Plus 1 over n cubed times the sum k equal 1 to n of k squared. Is that believable? And then what's the last step? Well, definitely not the last step.
Rewrite that in terms of bone formulas.
Yeah, this sum is n. This sum is n times n plus 1 over 2. And this sum is what? N times n plus 1, 2n plus 1, divided by 6n squared. That one might be. Is that correct?
That's just 6.
Oh, just 6, yeah. Yeah, thank you. Okay. So I get that? Now what? Now I need to set the limit when it goes to infinity and all that. What's going to happen to these limits? N over n goes away, so this one's going to be 9. What about this one? This is going to be a 6n squared on the top roughly and a 2n squared on the bottom. So that one's going to look like 3. After you do enough work to justify that. And then what's my leading coefficient here? 2n cubed over 6n cubed. So that's going to look like 1/3. So my answer is going to be 9 plus 3 plus a third. When I finally take a limit. I have a bunch of terms that go to 0. Right? Like this one, I'm going to have this 6n divided by 2n squared. That goes to 0 because you have a higher power n on the bottom. So some of these limits will go to 0 and shouldn't. That'll be your sketch. Definitely know how to do those problems. It's not on the quiz tomorrow in full detail, because I said I wouldn't include 4-3. But that is a skill we need, especially going into the test. On the quiz though, I could have you take a limit, or I could have you do, like, technically this part could show up on a quiz, because that was in 4-1. It wasn't until the only thing we had in 4-3 was we said this is also the area. So the area part that built it up was new, but computing this sum actually showed up in 4-1. Alright, so that's your other hint for tomorrow.